Okay, so I'm actually really excited about this problem. It's called apple and orange, and I've been reading about it a little bit. But basically, what we've got is this red line is our house, and we've got an apple tree to our left and an orange tree to our right. And what we want to know is for all of the apples and oranges that fall, how many of them land on our house? So we've got a bunch of parameters, and it's thinking about space in two dimensions. Um, well, actually, one dimension, right? It's just the x-axis. Um, it, did something fall on the house? And I've done a little bit of copy and pasting. So we've got S for the starting of the house, T for the ending of the house, A for the location of the apple tree, B for the location of the orange tree, apples for the number of apples that are actually thrown and how far they're thrown from the tree, and oranges, same thing. So it's going to look a little something like this. I've put these ellipses in to notate for myself that those are going to be arrays. I don't want to actually use that when we get to the function, though, because if apples is an array, as we've been told it will be, it would actually be this input would be one element long with an array inside of that element. So it would just be harder to access, which is not what we end up wanting to do. So I'm just going to take those out now. But to help me think through this, I've been drawing to myself a picture, which is going to be a little bit hard to see because I used a really light blue pen and took a couple notes. But what they really were was we've got two parts to this problem, right? Apples and oranges. So I'm going to start with apples, and then we should be able to basically repeat everything that we want to do for oranges. So distance from A for, so apples equals distance from A. Where do the apples land? So that's going to be apples of I plus A. So what I mean by that is we're going to go into each element of the apples array, and we're going to add to it the position of A. So one of the things that was in here was that if it's a negative number, it actually means that it falls to the left. And for apples, that means that it's definitely not going to fall in the house, so we can kind of ignore that. But since this is one continuous thing, when we get to the oranges, let's say that oranges starts at 10 and I've got a negative 5. Then 5, or negative 5 plus 10 is going to give me 5, which we'll see whether or not that's on the house or not. So then where do the apples land? And this is a new array. I'm going to keep them separate just to help me think through that. And then is that on the house? And the way that we're going to know that is we'll call this apple land, which will be fun. The way that we'll know if it's on the house is apple land of I is greater than house start, and less apple land is going to be less than or equal to house end. So house start is where the house starts on our one-dimensional axis, and house end will be where it ends. So if both of those items are true, then it's within the confines of the house, and therefore it would be on the house. And then we're gonna print or we'll have a count for the number of apples that this is true. So we'll be incrementing that. So we're gonna need a couple of things here. Let's let apple land equal let and actually I learned something new doing a problem a little bit ago that would be fun to try. So let apple land equal map of, let apples dot map and I'll explain what I'm going to try and do in just a moment, but apple okay, so what I want to do is, we know that the apples land at apples plus a. So if I think about the map of JavaScript, so okay, great. I actually do want to let apple land equal array 1, so that's going to be my apples dot map, and then x plus a. Yeah, that should work. So what we're doing is we're creating a new array, which is a map of the apples array, for where each element in apples, x, is mapped to a new element of x plus a being the constant of where the apples land, or of the location of the apple tree, excuse me. So we're going to just copy this right now for orange. Because it's on my mind. And then, so we've checked this off, right? And now we need to know, is it on the house? So we know house start, house end, but what we need to know is apples on house equals 0. So now we can do a for loop and go through the apple land, and if it's if these conditions are true, then we increment I've got a for let I equal to 0, I less than apple land dot length I plus plus, if let apple equal to apple land of I It's just a habit that I'm getting into of trying to be a little explicit on what I'm doing and not have to do this dot notation, hoping someone will one day tell me that I'm either doing something really clever in being explicit or really bad practice in adding extra lines of maintainable code. But that's kind of how I'm doing it. Obviously my code is pretty limited in size right now, so I'm not really, and I'm the only one dealing with it, so it makes sense to me to have very explicit variables, and that actually will ultimately mean that it's readable even without the comments. So I don't love their variables, so I'm going to rename them here. House start, house end, apple tree, orange tree. Okay. Okay, so for each item, for every item in the apple land array, which is the position that they land. So actually that may be apple land position. Then I'll have individual apple position. We want to know, is it greater than the housing start or less than the housing start, or housing end? Hopefully I did that. So housing start, housing end, if it's greater than and less than, then it's on the house. And that should do it for that. So from there, getting a little nervous about scope, so I'm going to want to think about that. It should be fine because this is the local scope, so within this block, I've got access outside of the scope. It's a little, the concerning part right now is just that VS Code tends to use this duller color when something is not being referenced, and that would be concerning. Orange. And that should do it. We're gonna see. Okay, so all their tests are actually written in with these as the variables. So to just try and make this easier for me. there it goes. Cool. Let's take a look at the submit. Did we pass all of the tests? And this is always the fun part. Hey, look at that. All right. Thanks for watching, guys. See you tomorrow.